20 grams of oxygen, how many moles do I have? 1 mole of O2 for every 32 grams. Then what I'm going to do is I'm going to convert that into moles of C2H6. So it is 2 moles for every 7 moles of oxygen. So I say I have 2 moles of C2H6 for every 7 moles of oxygen. And then I want to know how many grams that is. So for every 1 mole of C2H6, I have 30 grams. And I got that up here at the beginning. Right there. When I do that math, when I do 20 divided by 32 times 2 divided by 7 and then times 30 grams, I'm going to get 5.36 grams of C2H6. I hope that's right. Let's look down here. I have the answers all down here too. So you can go to the next page. Let's see. Oh, did I not? Alright, my bad. Come back here. And let's go to the, okay, so there you go. So yeah, so I should have, I should have 20, this is how much I need. That's how much I need. That's how much C2H6 I'll actually use. So then 20 grams of C2H6 minus the 5.36 grams of the C2H6. This is how much I was given here. This is how much I used or I needed. And I take that difference. And my answer then is 14 point, oh, sorry, hit the wrong button there. 14.64 grams of C2H6 in excess or left over. That's how much I'll have left over. And if you look back at the answer on this page, did I have that? Yeah, I just didn't put it into moles, into grams. But that's how much I should have left over. Alright, so it's a little bit different on this page. Let me pause it for 1 sec. So I taught this about a year, a little bit over a year ago, and when I made this worksheet. So let me just explain to you, this worksheet's a little bit different than the way I just worked through it. Alright, number 1, balanced reaction, same, cool. Number 2, or letter B I should say, limiting, or yeah, number 2B, limiting reactant, excess reactant. Alright, so what I did was I took the amount, make this a little bit bigger, I took the amount of my C2H6, I divided it by 30 grams, and I got the number of moles of the C2H6. Then I divided it by 2. Why did I do that? I did that because there's a 2 in the coefficient here. This is a shortcut, alright? It's a little confusing. It works because we're working with ratios, but it's a little bit confusing. So if this confuses you, don't do it this way. Do it the way that I showed you right here, where I'm converting into moles of one of the products. That's a better way to do it. Alright, this way here on this page. But this way it works perfectly well. It's just a little bit less explicit. It doesn't explain as well why you're doing it that way. So I have the this number here. This number doesn't mean anything. That's why I didn't put a unit next to it. Then I have the grams of the oxygen, 20 grams of the oxygen, divided by 32 grams. That gives me the moles of the oxygen. I divide it by 7. Why? Because there was a 7 here in my balanced equation. And I get a number. This number doesn't mean anything. It doesn't have a unit because it's not anything in my equation. But I compare these two numbers together. And when I compare them, 0.334 is bigger than 0.893. Therefore, the oxygen is smaller and it is the limiting reactant. So either way, I get oxygen as a limiting reactant. Whether I divide by the coefficient and compare the two numbers like I did here, or if I convert, and this is how I want you to do it for our class this year at HKIS, I take the number of grams of the reactants and I convert them into moles of the products. That's the better way to do it. And I look at it and I say, okay, this one was smaller number of moles of the products, so therefore this is the limiting reactant. That's the better way to do it. Let's look a little bit further here. Once I had the limiting reactant, which was the oxygen, I had the number of moles of it. I used the number of moles. I multiplied it times 4 moles of CO2 over 7 moles of oxygen, and I got the number of moles of the CO2. Then I multiplied it times 44 grams for every 1 mole of CO2, and I got the number of grams of the CO2 that I could produce. This is my theoretical yield. I did the same thing here. Moles of oxygen, 6 moles of water for every 7 moles of O2. There's my moles of H2O. I multiplied that times 18 grams for every 1 mole of H2O, and I got 9.64 grams of H2O. Now you look here, these number of moles. I stopped there on the previous page. That's okay too. It didn't ask me for the amount in grams. So if you look at 0.357 and 0.536, here they are, 0.357, 0.536. Same thing as the other page. If I wanted to, I could convert these into grams. I could say 44 grams for every 1 mole of CO2. And I can convert this one into grams of water, but I didn't have to. So either answer is perfectly all right. This one or this one. Last part. The amount of excess. Here, I use the limiting reactant, the moles of it, times the moles of the C2H6 over the 7 moles of oxygen. That's my ratio from the balanced equation. And I'll get 0.179 moles of C2H6 required for the reaction. Then I went up here and I took the amount that I required, the 0.179, and I took the amount that I had, 0.667. Where did I get that? I got that from right here. All right, I just took the grams of the C2H6 and I divided it by 30 grams and I got the number of moles of C2H6 that I had, and this is the amount of moles that I would have in excess. But you're saying, wait a minute. Over here you told me I had 14.64 grams in excess of C2H6. And then on this page, you're telling me that I've got 0.488 moles. Well, that is the same, it's just different numbers. 0.488 moles of C2H6 times 30 grams for every 1 mole of C2H6, all right, is 14 point, let's just, hold on, make sure that 0.488 times 30 is 14.64 grams of C2H6. The exact same number that I get right there, 14.64. All right, so I did it a little bit different. You can do it the way that I did it on this page with all the colored ink. If you need to check your answers, all the answers are on each page and the work is there. It's just done a little bit differently, okay? But they're still correct answers, and that's the video. Oh no.